Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Keto Man, who will be presenting on the topic of upgrading a legacy Java EE app with style. If you have any questions for Keto as we move through today's presentation, feel free to ask it in the chat or use the Ask a Questions tab. So, without further delay, Keto, over to you.
All right. Thank you very much, Serena.
Pleasure.
Hello. Hi. My name's Keto. Welcome to this Jakarta EE talk. The session, as she said, is about upgrading a legacy Java EE app with style. So basically, I'm going to be walking through a real live project, not in a lot of detail, but at a high level, where we upgraded in a legacy Java EE app. And we'll go through sort of the challenges we ran into and sort of how we went about that whole process. So while we get started, just a few words about myself. As we said, my name is Keto. I am the principal consultant at Virtua, which is my own company, it's virtua.tech. We do consulting, training, mentoring on front-end development and back-end Java, and, the whole gamut, whether it's cloud, whether it's mobile, whether it's, legacy applications, whatever. But basically, along the realm world of enterprise web application development. I am a Java champion, Google developer expert in web technologies, and I'm also the co-host of the Stacked podcast. If you like podcasts, I encourage you to check it out at stackedpodcast.com. There we discuss basically the things I'm talking about in general, like front-end development, back-end development, enterprise Java, a lot of JVM stuff, all those sorts of things. So you can check that out at stackedpodcast.com or in your favorite podcasting app. I wrote a JSF book a very, very long time ago. I participated in several Java community process expert groups over the years, and I'm also a Jakarta EE ambassador, which means I'm very interested in sort of ensuring that Jakarta EE lives and grows as a technology. All right, so that's it. That's me. I'd like to hear a little bit about the people in the webinar. If you could just spend a minute and just in the chat, just say, tell me if you have experience building Java EE or Jakarta EE applications, or if you're totally new to it, and if you're currently working on a migration or upgrade project. So if you could just type something in the chat, that would be great. Oh, we've got a quiet room today. Ah, there's a person. Okay. All right. No experience, new to it. Okay. So nobody has anything to say. So if this were an actual session where I could hear people, they would just be sitting there quietly. I've dealt with those audiences before. It's all good. All right. So,
Keto, we actually have Thad. Thad just made a mention here that he has 20 years of Java, mostly simple apps for Tomcat.
Okay, cool. All right.
Anyone else? Anyone else can add some more details here for Keto?
Well, thank you, Thad. All right. Well, I'm sure you guys have lots of interesting stories to say one day. So if you have anything to say along the way, just go ahead and type it in the chat, and I'll try to address it as possible, or when I can. So we know at least one of you has worked with Tomcat and Jakarta EE or Java EE before, which is cool. All right. So basically, what I'm going to talk about is a project where we were tasked with upgrading a legacy app to work with a recent supported version of IBM WebSphere. So WebSphere is a Java EE app server. There's also WebSphere Liberty, which is a Jakarta EE app server. But essentially, it's been around for a very, very long time. Very stable, very complicated, very powerful, but not sort of lightweight like a lot of the newer app servers. Although it is possible to get a Docker image, you can still deploy it in a cluster with Kubernetes, all that kind of fun stuff. But they were using an old version of WebSphere, and like most larger organizations, they like to have support, and this version of WebSphere didn't have support anymore. So they're like, hey, can you help us upgrade this old application? So I had the pleasure of working on this project with Walke Schultz, who is well known in sort of the Java Server Faces Java EE communities. He's a lead committer for Omnifaces, which is a library for JSF, and also wrote the definitive guide to JSF, a much newer book than mine. And if you ever have any question about Java Server Faces or anything like that on Stack Overflow, you'll find he has an answer there, a really good answer. So it's great to have him on the project. So it turns out what we needed to do was, in more detail, was move this application to a supported Java or Jakarta EE application server, integrate with a new cloud-based version of the app. So essentially, this application has been around for a long time. And what they had done was they built the entire application from scratch it's an insurance company for managing insurance claims and things like that. So they had migrated a large portion of their application and lots of lines of business to a new sort of insurance platform. It's Java based, but it's a proprietary insurance platform. So they'd migrated a lot of their code to that, but they still had a few lines of business running the old code as well. And they didn't have a plan to migrate those lines of code to the new platform yet. So we basically had to keep this application alive and running for their customers that were still using those older lines of business. And the plan was that eventually this code should be replaced in 2 or 3 years after we go live with the new platform that they're building or that they've already built. So that was the deal. Now, once we got into it, we realized there was one other thing that wasn't initially clear to us, which is that they needed to replace the existing security with Okta. And if you've heard of Okta, if you haven't heard of Okta, Okta is a identity management platform. So basically handles single sign-on for multiple applications within an organization. And you can also use it just for managing logins, for all of your users. So I've seen it used for external use cases and also internal. And this client was using it for both, using it for all of their users internally, single sign-on into their VPN and all that kind of stuff, and also for single sign-on for all of the external users using their applications. So we're like, okay, so we need to integrate with Okta. And I've worked with Okta before, but it turns out that the security that they were using for all of their users was actually in the legacy application. So we needed to replace that with Okta integration. So that ended up being a large portion of the project as well. So that's sort of the deal. So we had to upgrade the application, replace the security. So it turns out this application was first released over 12 years ago. And what's kind of cool is I was involved in the initial version of it. I helped kickstart the project 12 years ago. And it was kind of neat to go back to the source code and see my comments in there and things like that. So that was kind of cool. It was over 550,000 lines of Java code and over 550 web pages and includes. And only about half or less were in use. So like a lot of legacy code bases, there's a lot of code there, but not all of it is in use, but no one's gone and pruned out the dead code really. So you kind of have to deal with the whole thing. We of course only had to make the web pages work that needed to work though. And it turns out it wasn't just one app, it's really 4 different apps. So there was a back office internal web app, 2 public facing web apps, and there was also a set of SOAP web services. So how many people remember SOAP? Anybody? Just say +1 if you remember SOAP or you've worked with it. Oh, there's a plus. Okay. Anyone else? All right, a couple people. So most people think of web services now, think of REST. REST APIs. SOAP predated it, and it was heavier, all XML based. And because it was sort of heavier and more complicated, I think it kind of died once REST took off. But I've still, this is not the first project I've seen recently with SOAP. It's still around, and it follows the sort of general rule of software development, right? And most businesses, if it isn't broke and it's running in production, chances are it's going to run in production until it has to be removed or changed. So you'll still run into SOAP APIs if you work in large organizations. So we didn't have a budget to rewrite any of the SOAP web services. And it's questionable whether or not that would have been worth the effort. So we kind of stuck with SOAP. So those were sort of our constraints. That's sort of the story. And of course, we had to look at the Java EE app server, right? So that was the first thing. It's like, okay, well, they want to upgrade this to something new or something supported at least. What would that be? What does that look like? So before we had the WebSphere application server 7. And that's what everything was running on. And it was interesting. They're actually using Enterprise Application Archives, EARs. Anybody remember those? Anybody? Okay. So they're using those, and an EAR is sort of a special jar file that has multiple applications inside of it. Not very common these days, but back then that was a common way to deploy several related applications. So that's what we had before. And what we ended up with was WebSphere Application Server 9 full profile. We really, really wanted to move to WebSphere Liberty and take advantage of all the goodness and newer versions of Jakarta EE. And if you're not familiar, Jakarta EE is the successor to Java EE that's fully open source and managed by the Eclipse Foundation. So all of the vendors like Red Hat, IBM, Oracle, Tommy Tribe, and some others, they have Jakarta EE application servers. And those are currently the new versions, and they have lots of great features. They're easy to deploy in the cloud, all that kind of stuff. WebSphere 9 full profile is a little older. It supports Java EE 8. So it was like the last major version of Java EE before it turned into Jakarta EE. Because the main reason that we couldn't use Liberty was that we needed JAX RPC support. JAX RPC is what was underpinning all of the web services in the application. And the web service stuff was fairly complicated, so it wasn't really something that we felt like we could replace, as I mentioned earlier. So we kind of needed something that could support all that out of the box, and really nothing supported JAX RPC except for, WebSphere Liberty full profile. We could have looked at non-IBM products, but considering the fact that the client was already had a relationship with IBM for support and everything, we would have had to have a really, really strong use case for switching. So in the end, we ended up with WebSphere Application Server full profile. The other main reason for sticking with it was that this application was still going to be running on-prem. And it's good for the infrastructure team to know how to manage it. So although there's all sorts of other cool things we could have done, if we just said, hey, here's WebSphere Application Server 9, it works kind of like WebSphere Server 7, but it's newer. It's a much easier sell, and it's easier for them to maintain, et cetera, et cetera. All right, so that's the story with the app server. Let's also talk a little bit about some of the other areas. So they were using IBM JDK 6. WebSphere typically ships with the IBM JDK and generally only runs on the IBM JDK. I don't think you can very easily switch. They were using Java EE 5, and this means Servlet 2.5, JSP 2.1. They were using JSF 1.2. Which is pretty old, and they're using Apache MyFaces for that, and JAX RPC 1.1. So that's what we're stuck with. Something, pretty old application, JDK 6, and what are we on? 19 just came out, if I remember correctly. So pretty old tech stack. So what we were able to do, I should actually just take a step back. So one of the things we were very concerned about was the front end code. Right, and that's been the majority of what the application was, anyways, other than the web services. So Apache MyFaces is still around. We could still use that. We thought about maybe switching to a non-JSF framework if we found that the overhead was so much work that we might as well just rewrite the front end. That wasn't really the case. And since this application was only going to be around for a couple more years, there's really no logical reason to rewrite the front end if we didn't have to. So from JSF front-end perspective, the question was, well, what component libraries are available? JSF is a component-based Java web framework, and it has different component libraries. And the one that we used back then, several years ago, over 12 years ago, was Infragistics Net Advantage. Infragistics is a UI component developer. However, they discontinued this version of components back in 2009. And currently they have several other component libraries, but they're not really, other than Android, they're not really in the Java space anymore. Fun fact, I actually helped them kickstart that Infragistics Net Advantage a long time ago. I met there with their CEO and their CTO and everything at the time. So unfortunately, they killed it just during the recession after the bubble burst. So in addition to Net Advantage, they also had some of IBM JSF widget library. I didn't even know they were using this. So this was a library that used to ship with Rational Application Developer and IBM WebSphere. And they also use Apache MyFace's Tomahawk. So this was another component library which used to be around. It's not really active anymore. So they have 3 different component libraries mixed in there. So this was really where we were concerned about, because we're like, okay, if we upgrade this to a newer version of JSF, which we kind of need to do, are all the components going to break? Are we going to have to rewrite a whole bunch of stuff? And we don't really want to rewrite much, right? So that was one of the biggest questions. So let's look into this a little bit more. After we were able to, number one, upgrade to IBM JDK 8. That's the max version of the JDK supported by WebSphere 9, unfortunately. So as much as I personally prefer like 11 or 17 or something else, actually I think at the time 17 was, I don't think it even come out yet. So really the question at that point was to which LTS version, and we wanted to do 11, but we couldn't. JDK 8 was the latest version supported, so we kind of had to use that. And it turns out upgrading the Java side, the pure Java side, was really not a big deal at all. It was not hard to upgrade just the Java language code to JDK 8, which was really nice. And we also were able to update Java EE, update to Java EE 7. Actually, I thought it was 8 that it supported in WebSphere 9. But we were able to upgrade to a later version of Java EE. We upgraded to JSF 2.2, which was the version that was shipping with WebSphere 9, Servlet 3. And we had support for JAX RPC 1.1, which at that little graphic there means it's completely deprecated. But we were able to upgrade, get it all to work. So that actually, from a code perspective, all that worked fairly well. In terms of the component library, we were able to basically keep all of the components that we needed. We didn't have to basically get rid of anything. We did sort of remove some libraries that we didn't use, or some components that weren't very useful anymore, or that there was an obvious equivalent in JSF 2.2 for. But we didn't have to remove. We didn't have to remove an entire component library, which was pretty cool. So, and I will say, just the fact that we were able to do this without rewriting lots of stuff really does emphasize the ability for Java to evolve over time and to be upgraded fairly easily. And I think that's one of the biggest benefits. We complain about the backwards compatibility problem, right? That, Java doesn't move very quickly. They have to do all these things and support backwards compatibility. But what that means is that in a lot of cases, upgrading is not that difficult. So we're very pleased to see that. And that's true also for Jakarta and Java EE. So the fact that we were able to upgrade to a newer version of JSF, a newer version of JDK, and everything, and still use ancient components that were discontinued in 2009 is very, very cool. So we're very pleased to see that. That being said, everything wasn't perfect, right? So on the JSF side, the InfoJustice component, which we were surprised to see, worked with minimal changes with JSF2 and everything. The IBM Java Web components, most of them were removed because there were better alternatives that were just simple and didn't affect the functionality. So that was really the deal. It was really just going through all the pages, making sure that all the components worked and everything. So that worked out very well. The web services side was more of a pain, actually, turns out. So a lot of the problems we had were a lot of obfuscated errors where like we would get some, generic SOAP error, but there was really a bug inside of all the IBM code before it got to the error message. So the initial exception was completely obfuscated. So that was very difficult. And also on top of that, the error handling inside the application was very poor. So we had a lot of trouble tracking down errors. The other thing we ran into, and this is an interesting side effect. I think things are a little better these days, but a lot of the artifacts that were used were basically generated artifacts. So with JAX RPC, you basically would generate a whole bunch of code and then compile it and use it. And because of that, we had a situation where there was a lot of code checked in, but then there was a lot of generated code which wasn't checked in, and we had to track down where it was generated, how it was built. And it turned out the story was that the developers themselves were using Rational Application Developer, and it would generate all this code for them. And then they had some build scripts that were generating all that same code and deploying it. But to people who are just given all the code to look at, we had to sort of figure all that out. It was like, okay, well, where are the first generated code coming from? How did the developers even work with this to begin with? So we sort of made it fairly straightforward for new developers to work with. All the code generation is handled in the build now. And we actually standardized on using Eclipse for this project, not Rational Application Developer, but just the Eclipse Java IDE. And the main reason for that was because we wanted all the IBM tooling, the IBM WebSphere tooling, which of course is easy to find for Eclipse. Also, we thought at the time the developers were more familiar with Eclipse, although we learned that's not really the case. But we basically just set everything up so it was easy to use in Eclipse. So. And that's a big deal for me because I haven't really used Eclipse for years. So I had to kind of remember how it worked. I'm more of an IntelliJ guy, but Bake is an Eclipse guy, so that worked out well for him. So that's sort of the story with just the code itself. But like any project, there's more to it than just code, right? In addition to the code, there's also the security aspect, right? So I said initially that, we thought we were just migrating this one app, turned out to be 4 apps, also turned out to have security component, which we didn't really initially factor in. So it turns out that we had to worry about security for all the different applications, right? So for the web services, it turns out that initially, there was no security, which was fine, right? Because in that scenario, everything was running on-prem, right? The apps that needed to call the web services were just on the same network, and any other security for external parties entering in was handled externally before it even got to the web services. So the web services themselves had no security. So what we had to do was basically ensure that the web services could be accessed by new applications. So one of the things I haven't really mentioned is that it turns out once we started this project, we realized that it was really part of a much larger project, which was to migrate the newer application, which was on this insurance framework, to the cloud. So that was all on-prem, but we were moving that whole application to the cloud. So basically now we're going to be in a situation where the new code is all running in the cloud and the old code is running on-prem. So that means there needs to be security between the new cloud and the new code in the cloud and the old code running on-prem. So that was the story. So because of that, we had to have a machine-to-machine OAuth, and we used OAuth to client credentials grant type. In order to do that, we had to run a servlet filter, and we decided not to use any of the fancy SOAP security stuff. We just said, okay, we'll just use normal OAuth 2, and we'll write a servlet filter, and we'll just return a SOAP response if there are any errors. So it's sort of this weird hybrid, but it seemed to work out well. So they were able to connect from the cloud using OAuth 2, using the credentials from Okta to log into the web services. So that worked out okay. So for the public JSF apps, it was a little more complicated, right? Because now we're in a situation where initially, well, let me take a step back. So before, security was managed via the IBM WebSphere and IBM Security Access Manager. So that's basically how all of these sort of internal users were being managed. And then on top of that, normal users from the public users, they were accessing basically using custom database authorization using JDBC and DB2. DB2 is an older IBM database. And it turns out this strategy is being used for the new application as well, before it moved to the cloud. So basically, whenever you go into the application, you would log in through the old Java EE app, it would do the authorization, and then it would redirect you to this new front end in this new application. So basically, we had to replace the entire authentication mechanism for the old application with Okta, and then ensure that we could integrate with the new application. If someone were logging in through Okta into the new application running on the cloud. So that was the story. So we were able to do that again with a custom servlet filter and a custom servlet, and coming up with a mechanism for the users to actually get redirected to the old application if they're in the new application, because they kind of had to move back and forth. Yeah, so that was the story. So it took a little bit of work, but we were able to get it done using normal servlet filters and everything. And that was the story there. Turns out with the internal JSF app, we didn't have to do anything because it's all internal, and if you're in the VPN, they didn't really care as long as you could access it. So there we were good. So that was the story there. So there was actually a decent amount of work involved in all the Okta integration. There's still some of it going on actually because the project's wrapping up now. But we're able to get everything up and running, which is great. So a few pain points. The Okta docs are not so hot. So they look like they're great. They seem great, but then you realize they're missing details that are important. So there are a lot of questions you have, which is kind of a pain. The primary examples for Java are in Spring Boot, which is great if you're using Spring Boot, but not if you're not. So it takes a little bit more work. There are example servlets. There's plenty of example code out there, so it's not too hard to figure out. And also on my podcast, actually, we had Matt Rabel on recently, and Matt Rabel works for Okta. He wrote some of the Spring Boot stuff, articles and everything. And he's like, the docs aren't that great, but that's why we write lots of blog posts. So he's an evangelist there, or a developer advocate, I should say. So if you do end up working with Okta, just, FYI, keep this in mind, and then read the blog post from the developer advocates. So that's the story there. Okay. I should just, it's about halfway through. I've got more to talk about, but does anyone have any questions while we're got a very quiet audience here? Okay, I'll take that as a no. All right. Okay, so we talked about the code, we talked about the Java EE app server, but of course, and security, right? But then, of course, there's testing, right? So and testing is a very key part. I'm very into unit testing and integration tests, automated tests in general. I'm not really a TDD person. I wish I was. I've tried it before, but at the very least, I like to write tests and make sure that there are automated tests running on my projects. Um, when you're working with the legacy code base, you don't always have that luxury, though. So what we were able to do, though, is ensure that all of the existing unit tests work. So that would give us some coverage. They weren't really the best tests, though, and they also relied on an existing database, which makes them sort of flaky. But we did actually just try and make sure everything we had there worked. What was great is that we had dedicated manual QA to compare the older version of the app against the newer version of the app. So that was very handy. So obviously, if you're doing any sort of migration project, having QA dedicated to actually help you with testing is going to help out a lot. Their test coverage was not very good. So instead of going back and writing test cases for all of their code, knowing that the application is only going to be around for 2 or 3 years, we said, well, let's just make sure that for all of our new code or any code that we touch or refactor, let's try and write tests for that. So that's what we did, and it's we actually used Mockito, which is great for mocks and stubs. We didn't use anything fancy like Archillion, which is great for testing Java EE apps, and mainly because it would have been very time consuming and difficult to set up for this particular environment. And we didn't use any sort of front end testing tools because they didn't have those in place. And there was, of course, no budget for that because the integrating UI, writing UI integration tests, which I've done a lot of, is a pretty time consuming task. So we really would have had to have a separate budget for that. But we were able to get very good coverage for our new code with just writing ordinary JUnit test with Mockito. So that was good. All right, so documentation. So documentation is something that I find there seems to be a chasm. There's sort of like people who pay a lot of attention to it and people that don't, or don't ever write it or think about it, and not too many people are in between. But for us, it was very important. Number one, because there wasn't much to begin with. Number two, because as consultants, we want to ensure that when we leave, whoever has to maintain it in the longer term has an idea about how to do that. So initially, there's scattered, outdated documentation. Some in SharePoint, they didn't have a wiki themselves. And a lot of times you'd ask a question and then someone would send you a document. And even though we had access to their SharePoint, I don't remember seeing much on there that was terribly helpful. So that's the way it was initially. So we said sort of from day one, what we want to do is actually, maintain a wiki, and also ensure that all the documentation for the project was written, in the project itself. So, this is one of the issues that, or things to think about in general, is that documentation for code should be closest to code that you can make it. Although maybe some architecture documents and a lot of things like, different host names and environments and stuff, all that was on the wiki. On maybe how to do something with Okta, that was on the wiki. But when it came down to, the structure of the project, how to do a build, how to do all that kind of stuff. So all that kind of stuff we put in README files and other documents inside of the source control system. So there's a comment here. Probably a few people are missing out. I lost the first 20 minutes because there is no way to get to the meetup.com before stream. Okay. Sorry about that, Eric. Why don't we, once we get towards the end, if you have any questions, I can maybe fill it in. That might be helpful. So sorry you had trouble getting to the session there. So we made sure we had a lot of documentation along the way, and I think this has been very handy. And hopefully, when we leave, if anyone has to come back to work on this project, they will have some idea what's going on. So, okay. So, let me see, make sure I didn't miss anything here. Okay. All right. So another key thing is version control. So, in a perfect world, everybody uses Git, hopefully. And you're good to go. They give you access to the Git repo. You create a branch, or you have to fork it or whatever, but you're good to go. However, that wasn't really the case for us. So before, they had a legacy version control system called MKS Integrity. It was used only for this application. All their new stuff actually was all their current stuff, I should say, was in Subversion, and all of the code for the cloud effort was moving to Git. So from our perspective, it was like, we said, well, hey, I know you have your stuff in MKS, but why don't we just put it in Git now, so you don't have to deal with MKS, and then you don't have to worry about them and whatever licensing there is, because MKS is an older system it's a commercial product. And to be quite honest, we had no real interest in using it. So, but we were able to convince them to let us just put it in Git. Okay. So the problem, though, is that we did a clean break. We lost all of the history, and fortunately, they didn't really care. So that was good. Had they really wanted the history, that would have been certainly an issue. We would have had to figure out how to migrate that from MCAS. So we basically just took the code and put all of it in Git and just started from there. Now, of course, we ran into a couple issues, right? One is that the code we received wasn't the latest, and we didn't realize this till later on in the project, when there was some feature they thought should be there and it wasn't there, and we're like, well, why isn't this feature there? We didn't do anything to that part of the code. And then we found out, that there's some other class that had been changed since the version we got, so that caused some issues down the road. So something to keep in mind if this ever happens, that you need to somehow ask them to double check a few times to make sure it's really the latest code. And we also ran into an issue where some team members were not familiar with Git, and that's always a scenario if you're working with a team that's more familiar with Subversion, or another version control system. Git is always a learning curve, so that's just something you have to deal with. I'm wondering, how many people have worked with a version control system other than Git at this point? Anybody? Okay, one person. Okay, Subversion. Mercurial. Okay, cool. Oh, there's a CVS person. Wow, I remember CVS. Yeah, CVS has been a long time. All right, cool. Yeah, MCAS was not one I remember working with. I remember working with Star Team back in my Windows days. I think that was probably the oldest one. Perforce. Nice. Okay, so that's the deal with version control. And then there was build. So I haven't really mentioned much about that, but this turned out to be a big portion of the project as well. So what they had before was build scripts which were not in version control. So that was the first question. It's like, where's the build? Oh, it's on this random Windows machine. And it's like, okay, well, give me a copy of it. Let's see what the deal is. And it turns out the build consisted of Ant scripts, custom Java code, Jython scripts, all running on a Windows box. And it also used proprietary Ant-based JAX-RPC code generation tools. And that was what I was talking about before, where it was kind of weird that some artifacts weren't in Subversion. Weren't in version control, or weren't in the source tree. And it turns out that some of them were built using these during the build process, and then some were, and then the developers were using Rational Application Developer to generate the code locally. So the builds and deployments were done via simple Jenkins jobs. So they were using continuous integration. It was really just the build that was very old and archaic. And of course, it was generating three enterprise application archives. And as I mentioned before, EARs are basically huge jar files or zip files that have multiple applications in them. So they would have the web services code, a jar file of just business services, and then the front end code. So that was what they had before. So a lot of our work was basically going through and modernizing that. So we had a modern build. I should also mention that they didn't have any internal artifact repository. So there's no artifactory or anything like that running internally. So what we ended up doing was a few different things here. Let me. Okay. So we basically ended up doing builds and deployments using Jenkins, and I like Jenkins a lot. I know some people know Jenkins has some haters, but I like it a lot. And I was very happy to use the Jenkins pipelines. Pipelines has been in Jenkins for a while, and it's a really great feature for automating the build and also deployment via code. But what's cool is that you can do it using a Groovy, basically using Groovy as opposed to YAML. If anyone's coded in YAML before, you'll understand my disgust with that process. So I was very happy to use the Jenkins pipelines, which I've used before. So basically, we created build pipelines with Jenkins in Groovy. There is a multi-pipeline Bitbucket plugin that we use because we're using Bitbucket. So that allowed us to automatically handle building pull requests and different branches and things like that. And we had a lot of issues getting the build to run. So we'll talk about this in a second, but we ended up with a Maven project, right? And for whatever reason, we had trouble getting any builds to run on their current Maven, on their current Jenkins agents. So we basically created a new one using Docker and running Red Hat Enterprise Linux. So that was nice because it allowed us to have a dedicated build container for our builds. So that worked out well. Ended up with a multi-module Maven project and 4 wars. And we took out all the EAR stuff and just made 4 war files. And it turned out we couldn't get rid of all the Ant stuff because some of the deployment stuff that was specific to WebSphere uses Ant tasks, and there's no Maven equivalent. And fortunately, Maven makes it really easy to delegate to Ant. So we still had Maven for using the build, and then we delegated some Ant tasks when necessary. And those Ant tasks were primarily for the JAX RPC code generation. And remember, JAX RPC is for SOAP, and it's deprecated. So that's why the Ant tasks haven't been upgraded, because there's not a whole lot of demand for newer versions of this code. But this is another thing that's great about the Java ecosystem, is that these are ancient Ant tasks for some deprecated technology. We're able to just use it inside of an entirely new build. And say whatever you will about Maven, but it works great. And it's extremely flexible and powerful. So we were able to do that. We also found a WebSphere plugin for Maven that allowed us to do deployment from the Maven build. So that was kind of cool. So we were able to handle deployment to WebSphere using that. And what's interesting about WebSphere, and I'll take a step back here. So, we're all in this whole container world, right? Where we've got Docker containers and, running on Kubernetes, or some variation thereof, right? And what's interesting, if you go back and look at something like WebSphere and its console, it has all these abilities to start and stop, to manage clusters, start and stop clusters, add servers to clusters, all that kind of stuff. and it's sort of reminds me, it's basically like all of the network orchestration that you have with something like Kubernetes, but it's all at the WebSphere level, and everything is a WebSphere instance. So basically what our plugin did was deploy our application to different environments, which are running on different app servers in different clusters. So it was kind of an interesting way to look at things, and kind of reminds you that every time we move forward as an industry, we're basically just taking parts of things we've already done before and providing a new take on it. So, anyways, that's my soapbox. But I will say we got all that working pretty well. It's very smooth now. We can deploy to any environment, all through Jenkins, and run the pipeline, deploy via Maven. And Maven even connects to the external servers from the Docker container and does all this fun stuff. So it works out really well. What we found though is that this is kind of a funny quirk. So back in the day, WebSphere and Eclipse, back in the day for Java EE development, EARs were really the way to go. So it turns out that the Eclipse WebSphere tooling doesn't really even recognize WAR files. So we had to do this weird hack to get it to recognize WAR files. So just a funny little side effect of everything. So, but eventually we got everything working, and now it's really nice. We can just deploy any of the 4 web apps to any environment we want via Jenkins. So that's what we ended up with there. So a few pain points here. Let me move this over. There we go. So this was one of the very interesting pain points. So they didn't have their internal artifact repository. So there's no internal Maven repository, right? So we realized that several of the jars they were using weren't in Maven Central, and essentially they were all the jars were copied into source control. I'm sure many of you remember those days, and also they were physically on the WebSphere deployment servers. So basically, we had to essentially figure out how to handle this. There was not an appetite for installing a artifact repository. We did discuss it, but there was no uptake in that. So we ended up finding all the jars that we needed, which took a little bit of work. And because in some cases we had to upgrade, so it wasn't like we could just always copy the version that they had. And we ended up creating a local repo stored in Git. And essentially it's a local Maven repo. So it's not just copying the jar files into Git, it's basically a local Maven repo that happens to live in Git, which is not ideal, but seemed like the best choice for this particular organization at this particular time. So once we managed to get all that straight, we were able to get things going. And this way, we can still go grab stuff from Maven Central if we need to. But all of these sort of special libraries which have been discontinued or aren't available anywhere are in Git. We of course also ran into character encoding issues in source code because of Windows. And also we learned pretty quickly that some of these libraries required the IBM JDK. So any attempts that we made to get things working with a non-IBM JDK did not work. And again, that's specifically a WebSphere issue, not really something you run into with a non-WebSphere server. Integrating with Ant Task and Maven, and the code generation for DAX RPC was a fair bit of work. Just trying to get all that to work the same as it was before and making sure nothing broke. So that's the story there. And that was the build. Okay. So I think before we go to the takeaways, does anyone have any questions or any about what I've covered so far? Any questions or things that I've missed, or that you missed, I should say, that you want me to mention real briefly, and then I'll just go over sort of the key takeaways. It's probably mostly for you, Eric. Okay. All right. Well, if there are any more questions at the end, we can talk about them then. Um, so, a few key takeaways. So, I think one of the key things about this is that Java and Jakarta EE um, are extremely backwards compatible. And I think that's really the number one thing. I mean, we've got all this stuff working, and it's working quite well. And I think it'll serve them well until they have migrated their lines of business to the newer platform, um, which is also Java and JVM based, but it's different JVM language and everything. But I think this has been kind of a nice process to kind of go through. And also is interesting just to see how we were able to take it and just, we modernized the parts we could, right? The build is modern. It's got unit tests on newer code, integrates with Okta, all that kind of stuff. But it's still using a lot of really old code in there, right? All the business logic is old. We did not change business logic. All of those ancient JSF components, even though it's a much newer version of JSF, but it all works quite well. So I think that's one of the key things to point out here. Another thing is that when you're upgrading a legacy project, the code itself may not be the most complex or time-consuming task, and it wasn't for us. I mean, just the Java code wasn't a big deal. The JSF migration was, it took a little bit of work, a few weeks, but not that big of a deal. But what took the most time, honestly, was the builds, the CI/CD, and the Okta integration. Those were the things that took most of the time. Because not for the build, we had to basically redo the build because sticking with the old Ant structure just was not a good idea, especially since we'd already mavenized the entire project. We would have had to change the build anyways. So that was a big part of it. And of course, Okta integration was a major piece of work. So just keep in mind that what seems like it's the easiest may not be what seems like the major purpose of the project may not be what takes up all of the time and energy. Another key thing is that you want to change as little as possible. Going into a code base that's over 12 years old, you kind of want to rewrite things. You look at it and think, okay, why did they do it that way? Any code base that old is going to have a lot of cruft because different people have worked on it over the years. But unless your job is to rewrite it and refactor the code, you shouldn't be changing it, especially if it's business logic and you're not, a domain expert in the business. So you kind of just want to touch around the periphery. So we didn't really touch there's a whole business logic layer. We did not change any of that code unless it has something to do with accessing the database and we changed something along those lines, or if it had to do with security stuff that we changed or things like that that affected what we need to actually do. Another thing is that having the QA resources is, of course, very, very important. And you kind of are going to have that if you want to succeed, unless you have QA capacity yourself. And another thing that we try to do is make sure that things are easier for those who come after us, because you kind of look at it and think, okay, this is an ancient project. There's no documentation. Everything's all scattered. No one really knows all the answers. So since it's your job to gather all the answers, you might as well just write them down. Even if it's not perfect, at least someone who comes along after you has some idea, sort of where to go. So we try to provide instructions for people, like, if you're setting up a new project, this is how you do it. This is how the build works. This is the architecture for the Okta stuff, all that kind of stuff. So that at least if someone else comes along after us, they'll have some idea how to maintain this stuff. So. Okay, so I think that's really all I have. We can open it up to questions. If anyone else has any questions or any topic you want to cover in the next couple of minutes, I'll be happy to do it. All right, thank you, John.
Yeah, doesn't look like there's. Can you hear me?
Yep. Yeah.
Oh, awesome. Yeah, I don't think that there's any questions in the Ask a Questions tab. Um, no, I think we are good. So I wanted to
Okay.
thank you for the excellent presentation today, Keto. And just a reminder, again, if you guys have any questions while I'm wrapping things up here, feel free to go ahead and put them in the Ask a Questions tab or directly in the chat, whatever is most convenient for you. So the next Jakarta Tech Talk happens on May 17th. It's Jakarta Meal 2.1, Angus Meal 1.0. So you can register for that session using the link I will be posting in the chat. And also, if you have any feedback on the Tech Talk programs, we would love to hear from you. So just click on the green button that will pop up once we end this webinar and let us know if you've enjoyed the talk. So I'm just going to go quickly again, make sure that there's nothing in the Ask a Questions. No, doesn't look like there's anything there and nothing else in the chat. So thank you so much, Guido, and you have yourself an amazing day. And thank you for everybody who has joined us today. And we look forward to having you guys join us very soon.
Thank you very much, everybody. Thanks for having me.
Thank you so much. Take care, everyone.
Bye bye.
Bye.